In this video, I will explain you about the apparent depth. This you might have experienced in your life, that whenever you are looking from the top of a tank, you will see the depth of the tank as bit less than the actual depth. If the depth is, from the outside you can actually measure the depth. If the total height of the tank is 1.5 meters, but when you see from the top, it appears to be for you like it is having a length of 1.2 meter or less than that. Okay, now what is the reason for this apparent depth? Where we are seeing the actual depth as lesser, where we are seeing the depth as lesser as compared to the actual depth. The reason is, this is the point that gives us the inference about the depth. Okay, let's say there is no water inside the tank, it is fully empty. Now how we measure the depth of the tank, or how we inspect the depth of the tank? By seeing bottom of the tank, right? So we will see the bottom, and our eye would say that the bottom is a certain distance away from your eye or from the top of the tank. Now when the water is being filled, we will again see the point of inspection, process of inspection, and our eye would see a depth which is a different value. Now see, when the water is filled, which are the two rays which is receiving at our eyes? One ray would go in this direction. So this is the top level of the water. Now with the water, it is making an angle of 90 degree, or I can say with the normal to the water surface, the angle made is 0. So this will go without any bend. There is no refraction, or there is no bending occurring with respect to this ray. We need two rays to see, right? So this ray would tell me that the bottom point is somewhere in this line, but it can be any point. This can be here, anywhere in this line. Next point is, from here the light ray would be sent in this direction, would go in this direction, and at this point it would refract and go in this direction. So actually it was supposed to go in this direction, but it has got a bending, but it is away from the normal. And why it is away from the normal? Water is a denser medium, and air is rarer medium, right? This is how we have the actual scenario, from denser to rarer, from water to outside. Now in this tank, okay, now this ray would reach our eye. So we have two rays now reaching our eye. One is this and another one is this. So this ray is saying that the bottom point is somewhere in this line, and this ray is saying that it is in somewhere in this line. So the point of intersection of these two lines is here. So when we actually see, we would, from the top, we would see the bottom point at here. So this appeared to be the depth of the tank when we see on the top, because these two are the rays which we are receiving. So these rays, when we actually extend and find the point of intersection, that will appear to be here, not here. But when there is no water in the tank, there is no refraction. One ray would go in this direction and another ray would go in this direction. Now our eye can tell us the inference that the bottom point is either in this ray or in this ray. So taking the intersection, or taking the common scenario where the bottom point can either be in this line or be in this line, it should say that it is at the point of intersection. So we can actually see the depth. But here this is the point of intersection, and this would be the depth as seen by us. So we have to get the actual depth. So this is the apparent depth, apparent, and this is the actual. So this I am going to mark as D. So here I am going to apply sin I by sin R. So this is I, right? So if this is R, the whole thing would be R, opposite angle. The whole thing, this would be I and this would be R. Now if the whole thing is R, this would be R because this is an alternate angle. Now what is sin R from here? Sin R from that is equal to opposite PQ divided by hypotenuse, that is DQ. Divided by, sorry, this is sin R, right? We need sin I also. So this is sin R. Sin I would be, okay, so something divided by PQ by DQ, and sin I from here, if this is I, this would also be I. Okay, two parallel lines. So if this is I, what is sin I? Sin I is opposite PQ divided by opposite PQ divided by hypotenuse OQ. Okay, now PQ would cancel and the answer would be DQ by OQ. Okay, now we got DQ by OQ as the ratio sin A by sin R. Now when P and Q are very close to each other, I can say that DQ is approximately equal to PD, that is equal to, what is PQ? Equal to apparent depth. Apparent depth. Now at the same time OQ would approximately equal to OP. OQ is approximately equal to OP, which is the actual depth. Actual depth. Okay, so what is the consideration we have made? P and Q is close to each other. Close to each other. This is the approximation we made. Now I got the value sin I divided by sin R is equal to DQ. What is DQ? Apparent depth. Apparent depth divided by actual depth. Actual depth. Okay. Now sin A by sin R can be written as mu of rarer medium. So here it is air divided by mu of denser medium. Mu of denser. So refraction is occurring here, right? So wherever the refracted ray is, we have to consider the refractive index of that. So refracted ray is now in rarer medium. So rarer medium is air. This is denser medium. So just take the inverse of it. So refractive index of denser with respect to refractive index of rarer. Why I have done? I know that refractive index of denser is greater than refractive index of rarer. Anyway, this is equal to actual depth divided by apparent depth. And we know that refractive index of denser is greater than refractive index of rarer. So I can, if this is greater than this, the ratio would be greater than 1. Refractive index of denser divided by refractive index of rarer would be greater than 1. If this is greater than 1, this would also be greater than 1. So actual depth, actual depth by apparent depth is greater than 1. This says that actual depth is, just cross multiply, actual depth is greater than apparent depth. So apparent depth would always be lesser than actual depth. If this is the scenario, if the light ray is moving from denser to rarer, and that is the actual scenario what is naturally occurring from water to air. Even this would happen with other medium also, like kerosene to air, kerosene to free space. Okay, that's all. Thank you.